Hello and welcome to Simplifying Square Root Expressions. In this video, I will show three examples. The first example is the square root of 18. The second example is square root of 175. And then the third example is a little more complex. 21 plus square root of negative 245 all over 21. We will start with the square root of 18. 18 is not a perfect square, unlike numbers like 64 or 25 or 9. In situations like this is how you simplify square roots. You will break down the 18 into two numbers that would multiply to 18. They don't have to be the same. Well, when I think of 18, what comes to mind is 2 times 9. This is not the only possible combination. No, you can also do 3 and 6. Now I'm going to look at these two numbers and ask myself, which one can I break down further? Well, looks like 2 cannot be broken down. However, 9 can be broken down into 3 and 3. Now I'm going to look at the two numbers that I have on the ends, the two threes, and again ask myself if I can break it down anymore. And the answer is no, you can't. So 3 is not breakable and neither is this 3. So for the 18, the breakdown consists of the 2, the 3, and then another 3. Notice I am not using the 9 because 9 is really represented by the pair of 3's below it. To write the final answer for the simplified version of the square root of 18, all you have to do is find the pairs of matching numbers among the three numbers that I have circled, 2, 3, and 3. Well, it's clear that I have one pair of 3's. One number from that pair, 3 in this case, will go outside of our answer. And the number that didn't get paired up, a 2 in this case, will go back under the square root. The answer for square root of 18 is 3 square root of 2. Let's move on to the square root of 175. 175 again is not a perfect square, so I will be breaking it down. Well, 175 is divisible by 5. If you divide it by 5, the answer is 35, so that's the first pair. 5 cannot be broken down, so I will leave that alone, but 35 can be broken into a 5 and a 7. And again, neither one of these can be broken down anymore. So I'm looking at the breakdown. This 175 consists of 5, 5, and a 7. So 5s make up a pair. One number from that pair will go outside of the answer, 5 here. And then the number that didn't get paired up, the 7, will be back under the radical. For this last example here, I will first do the work that I have been doing with 18 and 175, but I will do it with this square root of negative 245. So for the square root of 245, I will actually keep it positive just for the time being, and then we'll go back to the fact that it was negative. So 245 consists of 5 and 49. Again, 5 is prime, you cannot break it anymore, but 49 is 7 and 7. Each of the 7s is also prime, you cannot go any further, so for the 245 you have a 5, a 7, and a 7. The pair is this pair of 7s, so 7 will be outside, and then 5 will be back under the radical. Now, my 245 was negative. The only difference that negative makes is that 7 square root of 5, this answer here, will have an imaginary unit I inside of it. You can put the I anywhere you like, just make sure that it is not with the 5 under the square root. So 7 square root of 5, I, is the answer to square root of negative 245 here. I will now plug in that answer where I have this blue circle. So this problem here becomes 21 plus 7 square root of 5 with an I all over 21. And once I have this, I'm able to simplify it a little more by splitting this large fraction into two smaller fractions, like so. So this first fraction will be 21 over 21. And the second fraction after the plus sign will be 7 square root of 5i over 21. And now each of these fractions can be simplified just a little more. So 21 over 21 here is 1 plus, and with the second fraction, I have a 7 that is outside of the radical right here on the top of the fraction, and a 21 that's also outside of the radical at the bottom of the fraction. And both of these numbers, the 7 and the 21, are divisible by 7. So I'll go ahead and divide each by 7, which will make this 7 into a 1 and this 21 into a 3. So the final version for the second fraction is 1 square root of 5 I over 3. And then most of the time you will see this written without this 1. So it's really just square root of 5 I over 3. And this will be the simplified version for this problem here with the fraction.